So now that we have the graph of the parent function of y equals tangent x, let's look at some of its characteristics. So first of all, with the domain, we can see that we hit every x value except the asymptotes. So the way you're going to write that is a set of all x's such that x does not equal, well, the first one occurs at pi over 2, and then it occurs every multiple of pi after that. So we're going to say x over 2 plus n pi, where n can represents any integer value. Now the range, we can see we hit everything. So that's going to be from negative infinity to infinity. The asymptotes are the ones we excluded from the domain. So their asymptotes are located at x equals pi over 2 plus n pi. Again, n is any integer. The zeros occur at, well, 0 is our first one, plus pi, 2 pi, so I can just say n pi, again, any integer. The period is pi, and this is an odd function. It is symmetric about the origin. Looking at the graph of cotangent of x, it's going to be very similar to tangent of x, but a few things are going to kind of shift around. So first of all, the domain, similar to tangent, it's going to be easier to eliminate things. So it's going to say the set of all x's such that x is not equal to the asymptotes here. So here the asymptotes occur at 0, pi, 2 pi, etc. So it's just going to be n pi, n representing any integer value. The range, again, hits every y value, so the range is negative infinity to infinity. The asymptotes occur at the same values that we eliminated from the domain, so simply vertical lines x equals n times pi. The zeros are going to occur at negative pi over 2, pi over 2, 3 pi over 2, etc. So we're going to say that's going to be pi over 2 plus n pi. You may start to notice that the zeros of the cotangent were the asymptotes of tangent and vice versa. And the period, similar to cotangent, is just pi, and then this is going to represent an even function. It's symmetric about the y-axis. For the function y equals secant x, we're going to see the domain. It's going to be the set of all x's such that x does not equal, again, the asymptotes, which occur at pi over 2, 3 pi over 2, etc. So we're going to say pi over 2 plus n pi. The range, now it's a little more complicated. So the range is going to be from negative infinity to negative 1, and I include negative 1. And then from 1 to positive infinity. The asymptotes, again, very similar to the points that we did, or the lines we eliminated from the domain. Pi over 2 plus n pi. The zeros, well, there's none. And the period, since it's the reciprocal of cosine, is going to be the same period. It's going to repeat every 2 pi. And this is an even function. It is just like cosine, it's symmetric about the y-axis. Looking at the parent function of y equals cosecant x, first of all, the domain, we're going to eliminate the asymptotes, the set of all x's, such that x does not equal 0, pi, 2 pi, etc. So n pi, where n is any integer. The range, just like secant, will be negative infinity to negative 1, including negative 1. And picking up again at 1, including 1, to positive infinity. The asymptotes occur at x equals n pi. The zeros, there are none. Does not cross the x-axis. The period, because it's the reciprocal of sine, is the same period of sine, which is 2 pi. And it is an odd function like sine, because it is symmetric about the origin.